Hey guys, happy Thursday. You should have two papers out. You should have gotten the blue paper off of the bookshelf, and you also should have gotten the puzzle as well. So first thing we're going to do is we're going to fill out the IMN sheet. We're going to be talking about proportions today and also doing proportions tomorrow. Remember, you can earn points today by doing a great job in class, doing what you're supposed to do, and having a great note left by the substitute. So let's talk about proportions. All right, so what is a proportion? So let's take our notes. A proportion, that's what goes in our blank right here. A proportion is an equation formed from two equivalent ratios, and we've been finding equivalent ratios on tables. So now all we're going to do is set it up as an equation, and it's called a proportion because that's what we've made. So how do you set up a proportion? When we are talking about proportion, labels and numbers matter. So remember when we did the apples and pies, we always made sure we labeled the apples and we labeled the pies, and if we set it up, the apples had to go with the apples and the pies had to go with the pies. So we said, okay, well there's 10 apples, that will make 2 pies. An equivalent ratio to the apples and pies could be 20 to 4. This is a proportion that we just set up. Making sure when we set up the proportion, we made sure we had our labels, and we made an equation. So proportions, setting up proportions are really important because the apples always are going to need to go with the apples, so they can either go side by side or they can go up and down. The pies are always going to go with the pies. You would never want your items diagonal from each other. These would be examples that are not proportional, but these are all proportional. They're all equal. So one of the things that they may ask you to do is find equivalent proportions to word problems. So we have a problem here, and what we need to do is we need to find the proportions that are equivalent to this word problem. Well, what I do is I don't look at those proportions that they gave me at all. What I'm going to do is I'm going to read the problem, and I'm going to set up the proportion on my own. And then I'm going to show you a strategy to help you find the ones that are equivalent. So let's look at our problem. If 2 lemons are needed to make 5 glasses of lemonade, circle all of the proportions that could be used to find the number of lemons needed to make 45 glasses of lemonade. So remember, I told you the labels are really important, so let's look and see what we're comparing here. We've got 2 lemons that make 5 glasses of lemonade. So this first part tells me my first part of my proportion. It also tells me what I'm comparing. I'm comparing lemons to glasses. And I was told 2 lemons will make 5 glasses of lemonade. And we want to find out how many lemons. So we don't know how many lemons, so we're going to put an L. That's going to be our variable for lemons. It would be needed to make 45 glasses of lemonade. So 45 is going to go down here with my glasses. So this is set up proportionally. Now what I have to do is I have to find the ones that are equivalent to what I did. Well, right away I can see this first one is definitely exactly what I set up, so that one's true. Now the other ones are not set up the way that I set them up, so how can I find out if they are equivalent to what I did? Well, one of the things I want to show you is you can circle the variable and whatever is diagonal from the variable. So remember, a variable is just the letter that we're trying to find out. It's the unknown, and we just circle that. And so when I circle the variable, I can see that I circled a 5 with it. So what I'm going to do is go to all of my proportions, and I'm going to circle the 5 and the L. If it is not diagonal from each other, it is not proportional. Here I have the 5 and the L, proportional. 5 diagonal from the L, proportional. The 5 is on top of the L, or if the L is on top of the 5, not proportional. So if you just circle, and let's go ahead and circle this one so you can see it is proportional. So that is the strategy we will use to find all the proportions that could be used to solve this problem. So let's turn over on the back. Now, how do we use a proportion to help us solve? So we've been doing this in class. There's different ways. We can look and find a multiplier, right? Find a multiplier. So what we're going to do is we're going to set up our proportion, and then we're going to look to see if we can find a multiplier. And that multiplier can either be within the ratio, or it can be between the ratios. So example 1, the recipe that Sylvia is using says 10 apples are needed for 2 pies. How many pies can she make with 55 apples? So let's take this first information. We've got 10 apples needed for 2 pies. So we're comparing again apples to pies, and I know that I have 10 apples for 2 pies. So what they give me in the beginning is the first part of my proportion equals, do I know how many pies? No. So that my x needs to go on the bottom because I don't know that. That's what I have to find out. 55 apples. So the apples have to go up here. So I have to figure out how many pies can I make with 55 apples. Well, I'm going to look for a multiplier. So the first thing I'm going to do is I'm going to go ahead and look within. So I can look and go, oh yeah, I know there's a relationship between 10 and 2. So I know that I'm going to go from the 10 to the 2 because I always point to what I'm looking for. I'm always point to what I'm missing. So I know that I have to do something to 55 to find my answer. So I know that to go from 10 to 2, what do? You divide by 5. So what would I have to do to 55? Divide by 5. And 55 divided by 5 is 11. So how many pies can she make? 11 pies. So we just found a multiplier, and we happen to find that multiplier within. And you can see how right here it says find a multiplier. Now let's look at example 2. Again, we're going to find a multiplier, but we're going to read it. The recipe that Sylvia is using says 10 apples are needed for 2 pies. How many apples are needed for 6 pies? So again, I'm going to go and look and see what they gave me. They said Sylvia is using 10 apples for 2 pies. So again, I'm comparing apples to pies. I know I have 10 apples equal 2 pies, but I'm looking for how many apples, so I don't know how many apples, so I'm going to put an X, are needed for 6 pies. Rather than looking within, remember, you can also look between. And I'm going to go from the 2 to the 6 because I have to go from the 10 to what I'm looking for. So what do you do to 2 to get to 6? Times 3. So what would I do to 10? Times 3. And 10 times 3 is 30. So how many apples are needed? 30 apples. Let's circle my answer. So we found a multiplier. On the first one we found it within, and on the second one we found it between. Now let's take a look at example 3. This time they want us to simplify the ratio, then find a multiplier, because sometimes there's not a multiplier right away. You have to simplify it. So yesterday Melissa rode her bike 4 miles in 14 minutes. Her goal today is to ride her bike for 70 minutes. If she travels at the same rate, circle same rate, that's telling you right there at the same rate to set up your proportion, set up your table. We're going to find out how many miles she'll travel in 70 minutes. Okay? So let's go back and get our information. The first thing they told me was she rides 4 miles in 14 minutes. So we're comparing miles to minutes. We know we can go 4 miles in 14 minutes. But we want to find out how many miles, so I've got to put an X for the miles because I don't know that, in 70 minutes. So I don't know what I do to 14 to get to 7. Actually I do, but that's not what we're supposed to do. We're supposed to simplify the ratio. So if you don't know, and you don't know what you do to 4 to get to 14, you can simplify 4 14ths. Remember, these are ratios. They act like fractions, and we can reduce fractions, so we can reduce this ratio. What can 4 and 14 both be divided by? 2. 4 divided by 2 is 2. 14 divided by 2 is 7. Now that I've simplified it, I've got a really nice multiplier. I've got a really nice relationship between the 7 and the 70. What do you do to 7 to get to 70? Times 10. So what would you do to 2? Times 10. 2 times 10 is 20. So how many miles will she travel in 70 minutes? 20 miles. And make sure you circle your answer. So we simplified our ratio and then we found our multiplier. All right, on example 4, they want us to find the unit rate. Oh, let me go turn the lights on, sorry. I haven't gone anywhere. There we go. It means Miss Tally's staying too late. But that's okay. Gotta make my videos. Okay, here we go. Sorry. Now on this one, they want us to find the rate, then find the unit rate, then find the multiplier. Now remember, the unit rate is when one of the values is 1. So we want to find, let's set it up and then we'll find the unit rate. Okay, so here we are at the Cypher candy shop. 2 pounds of chocolate cost $1.52. So we've got pounds to how much it cost. And we got 2 pounds, cost $1.52. And we want to say, and this is our hint right there, at this rate, tells me to set up a proportion. How much would 5 pounds of chocolate cost? So I know that I have 5 pounds. Do I know how much it cost? No. All right, so if I take a look at these numbers, I don't know what I do to 2 to get to $1.52. I don't know what I do to 5 to get to 2. So, but what you can do is you can find how much 1 pound of chocolate would cost. To find out how much 1 pound of chocolate would cost, all you have to do is take $1.52 and divide it by 2, because we bought 2 pounds. So I'm going to bring my decimal up. 2 doesn't go into 1, but 2 goes into 15 7 times. And when I subtract to get 1, bring down the 2. 2 goes into 12 6 times. And so 1 pound of chocolate is going to cost 76 cents. Now that I have it down to a unit rate, I can easily go from 1 to 5 now. 1 times what is 5? 1 times 5 is 5. So if I multiply 1 times 5, you've got to multiply 76 cents times 5. Ooh, why did I put 0.5? Don't put 0.5, just put 5. So let's multiply 0.76 times 5. And 6 times 5 is 30, carry the 3. 5 times 7 is 35, plus 3 is 38. Move your decimal 2 places. How much would we pay for 5 pounds of chocolate? $3.80. So we've done all 4 strategies to help us solve proportions. We have found a multiplier within. We have found a multiplier between. We've simplified our ratio, then found the multiplier. And then we found the unit rate, where 1 is one of the values, and then we multiplied. So we are not going to do this bottom part together. I feel like this is enough. Okay? So what do I want you to do now? I want you to go, and you've got this puzzle piece. Now, I'll be totally honest with you. The front of this page, if you get to it today, great. If not, this can be something you work on tomorrow, okay? But the back is definitely something that we're going to do today. So on the back, you've got, it's kind of random because it's a puzzle, but you've got 2, 4, 6, 8, 9 questions on the back. I'm actually going to do some of them with you just so I can help set you up, okay? All right, so let's do T together. We're going to do T, O, T. So here we go. The ratio of children to adults at a swimming pool is 8 to 3. If there are a total of 110 people at the pool, how many of them are adults? So we've got the ratio of children to adults is 8 to 3. So on this one, we're actually doing children to adults, but they give us the what? Total. So this is actually ratios, a table where you have 3 different levels. So here we have children. Remember, order matters. It's 8 to 3. But the total is not 110 because 8 plus 3 is how much? 11, right? So we know that we want to find out how many are there going to be if there's 110 people, right? So if there's 110 people, how many of them are adults? So we're looking for the adults right here. This is the one we're looking for. So we've got to look for, I don't even have to worry about the children here, I just worry about the adults. And let's look and see, what can you do to 11 to get to 110? That's right, we can multiply it times 10. So what would I do to 3? Times 10, because this is equivalent. What's 3 times 10? 30. So how many adults are at the pool if there's 110 people? 30. And if I want to do the kids, just multiply that by 10. 80 plus 30 is 110. Makes sense? So this is a triple decker, I like to say. Let's see which other ones are going to be triple deckers. 11, let's put a star by H, I'm sorry. Put a star by H, that's going to be a triple decker. And E is going to be a triple decker. So those are going to be just like T, okay? T, H, and E are all triple deckers, okay? All good? All right, let's look at O. Okay, a dozen roses cost $21. At this rate, that tells you right there, hey, I can set up a proportion, right? How many roses could you buy for $49? Well, let's look. A dozen is how many? 12. Okay, so we've got roses to cost, or cost to roses. I guess I should put roses to cost, sorry. I guess technically it doesn't matter, but roses to cost. So we know we can get 12 roses for $21. I want to find out how many roses, so I don't know my roses. I'm going to put an X there. I could buy for $49. Now remember, you've got to look for a multiplier. See if you can find a multiplier within, between. Well, I look at 12 to 21. I don't know what to do to 21 to get to 12. There's not a multiplier there. I don't know the multiplier between 21 and 49. So what are my other options that I can do? Well, if you take a look at your notes, remember, we can simplify the ratio, right? So let's see if we can simplify this ratio. Look at 12 and 21. What can 12 and 21 both be divided by? 3 would work. 12 divided by 3 is 4. 21 divided by 3 is 7. Now I've got it simplified. Can I find a multiplier? Well, yeah. 7 times what gives me 49? 7 times 7. So what would I do to 4? Multiply it times 7. 4 times 7 is 28. So how many roses could you buy for $49? 28 roses. Okay, last one I'm going to do with you is T. And I'm really not going to do all of it for you. I'm just going to kind of do one little section for you. I'll help you set it up, and then I'm going to let you finish the rest. A bathtub holds 80 gallons of water. Water drains out of the tub at a rate of 2 gallons every 30 seconds. At this rate, so that tells you right there, hey, I got to set up a proportion. How many minutes will it take a full bathtub to drain completely? Well, if I look at what they gave me in the problem, it gave me gallons and seconds, but they're asking me for the minutes. So here's what I want to do. If I can do 2 gallons for 30 seconds, how many seconds are in a minute? 60. Yeah, so couldn't I double 30? Multiply that times 2. That would give me what? 60. That would be 1 minute, right? So this would equal 1 minute. But if I double 30, what do I have to do to this too? Multiply it times 2, so how many gallons would that be? 4 gallons in 1 minute. So we're going to set this up as gallons over minutes. So I know I can have 4 gallons in 1 minute. But I know the bathtub holds how many gallons? 80. So how many minutes would that be? Well, there's a couple ways you can do this, but I would probably go from 4 to 80. Okay? All right, so here's what I want you to do. I want you to finish the ones on the back. If you finish all the ones on the back, there will be a checking sheet at the back of the room. Go to the back of the room and check your answers. Then, once you check it, work on the front. Okay? Down here, it's 2 more proportions that you can set up to solve. And all you're doing up here at the top is writing each ratio in the simplest terms. You've got an answer bank up here that can help you. Okay, use the picture right here for section 1 and section 2. All right, guys, have a wonderful day, and you'll get to watch my video tomorrow, and I hope you have a great one. Bye.